Okay, as we jump into our lesson here, just a quick review, some ideas from Algebra 1, help get us started into our Algebra 2 course. So there are various number sets that we use in our different math classes. Let's just kind of review them. So first of all, when you first start counting back in elementary school, 1, 2, 3, those are called the natural numbers, or sometimes the counting numbers, kind of the most basic number set if you want to imagine that. Well, then you added this idea of a number 0, right? That kind of an empty number, placeholder. That's the same as the natural numbers. The only difference is you've added a 0 now. We call that the whole number set. Then your universe expands and you learn about negative numbers. Oh, there's a -1, a -2, a -3. Of course, they keep going forever in both directions. We call those integers, and we work a lot with those. Then our universe expands even more, and we learn about decimals and fractions. Of course, you go back and forth between those, right? And we call those rational numbers. That's this bigger set. All these other numbers, by the way, and that's what these boxes are trying to illustrate, all these other numbers fit in the rational numbers. So natural numbers are whole numbers. Whole numbers are integers. Integers are rational numbers as well. Because of course I could write 1 over 1, for example, or 2 over 1, or 4 over 2. That would be the same as 2, right? Well, there's this other number set. Out to the side, let's talk about irrational numbers. Irrational meaning not rational, right? Most of our square roots are like that. Pi is a very famous example. A lot of cube roots, different radicals. So these are numbers, if you plugged them in a calculator, they're going to just go on forever. The decimal is going to keep going. It's not a nice repeating decimal. So for example, if you did 2/3 in a calculator, that would be 0.6666. It would go forever, right? So that repeats. If you did square root of 3 in a calculator, it's not going to repeat. It just keeps on going. So those are irrational numbers. And all of these numbers fit into this grander number set that we call the real number set. Okay? And so you're going to identify these a little bit. It's just going to ask you some questions in the lesson, maybe on the practice quiz, just to identify and group these. So just keep this close. It's not that big a deal. Just want to identify these. Okay, let's go look at a quick example. So, the number of times a cricket chirps in 1 minute is represented by n. Which set of numbers best describes the value of n? So the number of times a cricket chirps. So if you sat and counted those, let's think about it. Well, that's just going to be some normal number. 1, 2, 3, 4, 5, right? So which set of numbers best describes the value of n? Well, it's going to be a natural number. We just said a counting number. Integer, right? A natural number is an integer, but integers have negative numbers. Is that going to be negative? No. Irrational, like square root of 3, something like that? No, that doesn't work. Whole numbers, remember that's our natural, but it also has 0 in it. So which set of numbers best describes, well, I guess if it had 0 there, but to me, natural numbers sounds like it's just the one that's going to be the most natural that goes with that question, okay? How about something like this? They ask us maybe just to compare a few things. Compare 5/3 and 1.6. Now that bar over it means it keeps going, right? 1.66666. Again, these are pretty straightforward. I'm not trying to insult your intelligence, just kind of review a couple ideas with you. Of course, one thing you could do is just plug this in a calculator. 5/3, what is that? Here's Desmos, by the way, a great tool I'd encourage you to use. 5/3 is 1.6 repeating, it looks like. And so it looks like those are probably equal. Remember, this is greater than. This would mean 5/3 is bigger than that. 5/3 is less than, or 5/3 is equal to. And so I like that one there. How about this guy? Negative square root of 4 and -4. Well, what does square root mean? Remember, square root of 4, what number times itself equals 4? Well, that equals 2, doesn't it? So square root of 4 is 2. So this is actually saying -2 something -4. And now we need to be a little cautious, right? -2 something -4. Well, -2 is a larger number. If you picture a number line, right? Negative 4, here's negative 2. Negative 2 is to the right, and that is a larger number. And so this looks like our winner there, okay? Not too big a deal, but let's just review these properties real quick. It's going to ask you a little bit about them. And again, I don't think these terms are that important necessarily, but we want to understand how they work. Let's talk commutative property. Look at that word commute right there. If you think about a commute, driving to school, driving back home, driving to work, driving back home. Same distance both ways, right? Well, commutative property, addition, multiplication just means that if you reverse the order, you get the same thing. So 2 plus 3, same as 3 plus 2. 2 times 3, same as 3 times 2. Hey, that's commutative property, not a big deal. Associative, you think like associate in there. Who do you associate with? Who do you group with, right? Well, this is just grouping. That's where you introduce parentheses. So you group some stuff, it equals the exact same. Not too big a deal. Identity is a very basic property. I'll just let you look at that. Inverse, again, very basic property. Just look at that. Distributive, very familiar with probably. You distribute something. So A times this, right? If you see it out front, just means you're going to distribute it through, multiply it through both things. You get AB plus AC. So again, pretty straightforward there, I hope. Absolute value, let's review. So absolute value is the distance from 0, okay, on a number line. Distance is always positive, right? I can't have a negative distance, so absolute value will always be a positive number. Let me just illustrate that real quick. So let me just freehand a number line here. So let's say there's 0. How far is 3 from 0? Or I'm basically saying, what is the absolute value of 3? And remember those bars, that's how we represent absolute value. Well, what is this distance right here? Well, it's 3 units, right? How about if I go out here? Negative 3. How far is negative 3 from 0? Or in other words, what is the absolute value of negative 3? Well, what's this distance out here? Of course, it's 3 units as well, isn't it? Whether you're standing here or here, it's just a different direction from 0, but they're both 3 units. That's all absolute value means. Let's look at a couple quick examples. Simplify the opposite, okay, or negative, absolute value 12 minus 7. So let's just simplify this. So negative, what's 12 minus 7? Well, 5. What's the absolute value of 5? Well, it's 5. And I still have that negative out front, or the opposite of, and so I get negative 5 there. Okay, I'm going to show you another way we could check that. Simplify this. Well, what's 3 minus 6? Negative 3. What's the absolute value of negative 3? Notice that's all inside now. And of course I get 3 there. And that would be my answer. One other quick thing. Let me just show you in decimals. And those are easy problems. I hope you're saying, okay, this is easy. But you could type absolute values right into decimals as well. And so like if I want to do this problem, maybe to check myself. Negative absolute value 12 minus 7. Hey, there it is. Good way to check yourself, maybe just visualize, especially as we get into more complicated problems, some things down the road, okay? So I hope that'll help get you started, and go through, work things out, work examples, write them down, take some notes, and you ought to be in good shape.